Hi there. Ben and Sally will be in here very soon, and boy are they in for a long afternoon. During this past week in our JSC Mathematics series, we have been discussing mensuration. That's a scientific word for the measuring of different shapes. This is our last lesson, and we plan to bring all those formulae together in one place, here. So, we are going to make sure we understand and know how to use the formulae for calculating the perimeter and area of a circle, parallelogram, kite, and trapezium. That's what you'll have to do in the exam.
Shoo, we have a lot of homework today.
Yeah, the sooner we start, the sooner we can finish.
Yes, you're right.
After you.
Measuring is the activity we do to find a number that shows the size or the amount of something. We can measure many different things: length, height, volume, mass, and time. We can even measure temperature, speed, and direction. But in this series, we have been concerned mostly with perimeter and area, how to calculate the values using formulae, and doing those calculations to determine the distance around and the area inside of various shapes. We looked at circles and at quadrilaterals like the rectangle, the parallelogram, kite, and the trapezium. That was good. Now, let's get moving, because we can measure time, but it is not stopping for us.
I've got the list of homework instructions here.
Okay, I'll read it out. First one, find the area of the shaded region.
Okay. First, we must look at what shapes we have. The shaded region is the background. It's a rectangle.
But it excludes the white form in the foreground, which is a trapezium, if I'm not mistaken.
Yes, it's a rectangle, and inside the rectangle is a trapezium. But they want the area that is inside the rectangle, but outside the trapezium. I think we have to subtract.
Yes. First, we have to find the area of the whole rectangle. The dimensions are given. The lengths of the two sides are 8 and 12 centimeters. The formula for the area of the rectangle is length times breadth. Are you writing?
Yes, of course. Area of rectangle is length times breadth.
The length is 12 and the breadth is 8. The answer is 96 centimeters squared.
Okay, I've got it. Now for the trapezium. Let me just make sure again of the formula. It's here on the screen. The formula for the area of a trapezium is half times sum of parallel sides times height.
Gotcha. But how do we know which sides are parallel and which is the height? Well, look at the sketch again. The line that forms a 90-degree angle with one of the sides is normally the height. There are two right angles marked. So, it seems that the parallel sides are 3 and 5, and the height is 5, the bottom line here.
Okay, let's see how it works out. Area is half of the sum of parallel sides times height. This means half of 5 plus 3, which is 8, times 5. Half of 8 is of course 4, times 5 is 20. The answer is 20 centimeters squared.
Right. So we are 2/3 of the way there. Now, To find the area of the shaded part, we subtract, as you said earlier. So it's 96 minus 20, and the answer is 76 centimeters squared.
Good. Let's look at the next problem. Here we have a rectangle inside a kite. They want the area of the shaded part again.
So it's the same. We just find the areas of both and subtract the two. What's the formula for the area of a kite?
First, let's work with the rectangle. Area of the rectangle, as we know, is length times breadth. So it will be 9 times 4, and the answer is 36 centimeters squared.
Okay, got it. Now for the formula of the area of a kite. It is half times diagonal 1 times diagonal 2. But, oh shucks. So, we don't have the diagonals. What do we do now?
My goodness. No, Ben. I don't know how we are supposed to find the diagonals. All we have are the lengths of the sides of the rectangle. The kite sides are obviously shorter.
We don't have time to waste. We should call Miss Winters. It's ringing. Oh, hi ma'am. It's Ben. I'm so sorry to disturb you, but I'm here at the classroom at 7. And
I'm on my way. I'm on my way to the class, Ben. I'm almost there.
oh, we'll wait for you then, ma'am. Thank you.
Imagine my 2 favorite learners slaving away doing their homework in my class.
Good afternoon, ma'am. We're only on our second one now, and we're struggling.
Okay, show me.
See, ma'am, with this problem, they want the area of the kite, but they don't give the diagonals.
But with a bit of logic, you can work out. Look here. The length of the rectangle is 9 centimeters, right? It is always a good idea to work out the diagram and show as much information as you can. Did you think to draw the diagonals of the kite? Do that and see if it helps.
Yes, we will do that. If I draw a line through the kite from left to right, joining the points, that will be the long diagonal.
And there you have the long diagonal. It's the same as the rectangle's length, 9 centimeters.
And we do the same with the line that runs down, the short diagonal. It is the same as the breadth, 4 centimeters long.
It's true and so logical. I'm so sorry I had to come in just to bother you with such a silly question.
It's okay, Ben. You did not disturb me. I was a few seconds away. I was coming to do some work myself. But since my classroom is occupied, you might as well go ahead. I'll do some cleaning here at the back. And please, do call me if you need any help.
Thank you, ma'am.
I appreciate the dedication.
Thank you, ma'am. Okay, where were we? Oh yes, we're at the area of the rectangle. It was 36 centimeters squared. And now, we know the lengths of the diagonals are the same as the length and breadth of the rectangle. So according to the formula, the area of a kite is half times diagonal 1 multiplied by diagonal 2. This is then half of 9 times 4, which is 36. And half of 36 is 18. So the answer is 18 centimeters squared.
Don't forget now, we need to subtract the area of the kite from the area of the rectangle. We do 36 minus 18, and the answer is 18 centimeters squared. Done! Wow, this is easy. I don't know why I thought we would struggle so much.
Yes, once you know all your formulae, it is not that difficult. What is the next example?
Here it is. Calculate the shaded area of the figure. Goodness, there are 2 circles.
You're not serious. All we're given is the length of the rectangle. That doesn't seem like enough information.
Well, at least Miss Winter is here. Let's first see how far we can get on our own.
Okay, I see a rectangle and 2 circles. And one side of the rectangle is 16 centimeters.
So where do we get the breadth?
Think, Beno. You know what, Sally? Look at these circles. Because of the rectangle running horizontally, we think automatically of the circle's diameter of running that way. But the diameter is the same in any direction, isn't it? Let's try and draw on the diagram again. So, look what happens if we draw in a diameter and let the diameter run parallel to the breadth or width of this rectangle.
It tells me that the diameter of the circle is the same as the breadth of the rectangle. Good going, Ben. But we still don't know what the breadth of the rectangle is because we don't have the length of the diameter.
Aha! But we do see that 2 circles fit exactly into the space of 16 centimeters. Let's draw in diameters of the circles.
Oh, so the diameter of 2 circles is 16 centimeters, meaning that the diameter of 1 circle is half of that. It's 8 centimeters. How clever you are, Ben.
Logic does it, mademoiselle. So the diameter of the circles is 8 centimeters each because they are the same size. Now if the diameter is 8 centimeters, the radius will be 4 centimeters. And as you said, the breadth of the rectangle has the same dimension as the diameter of the circle because you can also draw the diameter from top to bottom.
Oh, I see. So we have 2 circles with radius of 4 centimeters each. The breadth of the rectangle is 8 centimeters. Now we have enough information to continue.
Yes, we can start with the area of the rectangle. Write down area equals length times breadth. So it will be the length 16 times the breadth 8, which gives us 128 centimeters squared.
Now for the area of the circles. Area is, let me see, there on the board. Yes, pi times radius squared. So, I take the value of pi on the calculator times 4 squared and I get 50.265. This is not the final answer, so we don't round off yet. Yes, but there are 2 circles, remember, so we have to multiply the area of the circle by 2.
That's fine. The area of 2 circles combined will then be 50.265 times 2, which gives us 100.53 centimeters squared.
And only now do we do the subtraction of the white shapes from the area of the rectangle to find the shaded area. The shaded area is the rectangle area 128 minus the areas of the 2 circles of 100.53. I get 27.47 centimeters squared. Now we round off to 27.5 centimeters squared as the final answer.
Wow! We've got it.
Yes, not bad. We are on a roll. Oh, look at the next example. Here we must find the perimeter, not the area of the shaded part.
Oi, another one of those. Can we do an easier one?
Let's see. Maybe it's not really difficult with your logic and my calculations.
That one is not so difficult, you two. You just have to know what is meant by the perimeter of the shaded part.
Well, perimeter just means the distance around a figure. It's not that hard.
Yes, I always tell myself there's a little man walking from his starting point and he walks around the shaded area until he's back at the start again.
That's a good idea.
Yes, and it is the same as the radius of the circle. That's 25 centimeters.
Then he turns to the right and walks all along the length of the rectangle, which is 50 centimeters.
And then he turns right again and walks down along the breadth of the rectangle another 25 centimeters.
Now he walks along a semicircle to get back to where he started.
Yes, that's what I mean. So there are 4 parts to the perimeter of the shaded area. We have to add the breadth plus the length plus another breadth, and instead of another length, it is the circumference of the semicircle. Remember, we are just talking about the shaded area now.
Gotcha! So the perimeter is 25 plus 50 plus 25 again, plus pi multiplied by the diameter divided by 2. Is that correct?
Yes. And remember that the diameter, which is 50 centimeters, forms part of the calculation. It is the same as the long side of the rectangle. Even though it is not part of the shaded area, we need to work out the circumference of the semicircle.
Okay, I understand. 25 plus 50 plus 25 is 100 already. And pi times 50 divided by 2 is 78.54 centimeters. So now, if we add them up, the answer, the perimeter of the shaded part of the figure is 178.54 centimeters, which we round to 178.5 centimeters.
Good. Guess what, Sally? We have just one more problem to do.
Yay! So shoot!
Here, we must find the perimeter of this figure.
Ooh, it looks like those pictures they used to test where the people see a hollow tree or 2 round balls facing each other.
You're right. Well, we'll have to make sense of it if we are to work this out. You can see that it could be a rectangle to begin with. There are 2 lengths, each 32 centimeters, and then we have a breadth of 20 centimeters, but the rectangle is not complete. Of course, the sides are rounded inwards.
Yes, it looks like we'll work with a rectangle and 2 circles again.
Enough talking. Let's begin. It's not so hard. It's just the outline they want. 2 of the sides we already know. 2 times 32. That's the perimeter of the straight lines, adding up to 64 centimeters.
Okay, let's have a look at those 2 semicircles. There's one on either side. And we can use the short side, which is 20, to get the circumference of the circles.
Sounds good. Let me write it down. The perimeter of a semicircle is half of the circumference of the circle, but there are 2 of those. The circumference of one semicircle is half times pi times diameter. That's half of pi times 20, and it comes to 31.416. But we double this to find the circumference of 2 semicircles. That is 62.83.
I see. And then the total perimeter is the perimeter of the straight lines. 64 plus the circumference of the 2 semicircles. 62.83. The total is 126.83 centimeters. We round off the final answer to 126.8 centimeters.
Once we know what to do and we have the correct formula, it's easy to put the numbers in, isn't it?
You mean we're done?
We're done?
And if you'll excuse me, may I have my class to myself? Well done and goodbye.
Bye, Mrs. Winter.
Thank you, both of you.
Phew! Viewers, that was a bunch of problems to solve, but you did it, and we are proud of you. Let's now quickly go through the main points again. When you have to find the area of a shaded region, you first have to identify the types of figures. Then, you find the area of both figures and subtract the smaller area from the larger area. To find the perimeter of a figure that has more than one figure in it, imagine you are walking along the line until you reach the same place as where you started. Outline the shaded area and count the number of parts you need to add up. Then, add up all the distances you covered, which will give you the total perimeter. When you move along a circular line, use the formula for the circumference of the circle. Deduce whether you are working with a full circle, a semicircle, or even a quarter of a circle. But before I say goodbye, here is our final SMS competition question. Today, the key word for this program is quadrilaterals. By now, you will know how to spell that quite well, don't you? You have seen this diagram before. It shows a vegetable garden in the shape of a rectangle from which two semicircles have been removed. The diameter of each semicircle is 8 meters. For this question, you are required to find the perimeter of the shaded area. Remember, we want the perimeter of the garden. Tell us whether the perimeter of this garden is A, 43.1 meters, B, 47.1 meters, or C, 38 meters. SMS your answer A, B, or C to the number 5003. Don't forget to first put in the keyword quadrilaterals. I hope you have enjoyed these 5 lessons from NAMCOL on measuring. We wish you success in the upcoming JSC exams. Goodbye.